Hello, my name is Mr. Asprey, and this is my Edexcel IGCSE exam series where I go over every topic. And this is the second time I've done it, and this is 3D Trig. Now, it is very close to November 2024 Edexcel IGCSE Maths exam. If you are doing that exam, then please do let me know in the comments. I'm thinking about putting on revision sessions and live streams. But I need to know like how many people are doing it. I've got no idea, and whether or not you are keen for me to create that content. So do let me know in the comments, and I will see what I can do if the numbers are good. Okay, right. Let's get into 3D Trig. Now, 3D Trig is all about drawing 2D triangles on a 3D diagram. We've got a horizontal rectangular field, and we've got a vertical pole AE, and it's placed in the corner, and it says calculate the size of the angle between EC. So the first thing I'll do is I'll draw on EC, not like that. There we go. And the plane, which means 2D surface, ABCD, so the base, the rectangular base at the bottom. Give your answer to one decimal place. Okay, so we've drawn the line C to E, and then we've got the line AE, which comes straight down, and then the next thing we do is we draw a line along that plane that's going to connect up A and C just like that. And this will create a right angle triangle, and we know already one side of this triangle is 12. We know that we are looking for the angle between EC and the plane. So it'll be this angle in here. Let's call it X. I needed one more bit of information before I could work out that angle. And that is going to be this line here, AC. This one along there. Now, AC is part of that rectangle. So I just draw the rectangle out like this. And AC will be this line here, because it's part of the rectangle ABCD, and that is 18, and we also know that this side is 8, which means this side is also 8, and it's a rectangle, so it has a right angle, so we can work out AC by doing Pythagoras' theorem. So it's the square root of the two short sides squared and added together, like so. So we can go over to our calculator and we can just press square root 18 squared plus 8 squared, and we get 2 square root 97. Now I'll leave it like that. I won't bother writing the decimal because we're not because we're going to use that value in our calculator anyhow. So we've got this lovely triangle here now that we could use trigonometry on. So it's this yellow triangle which we're going to use, and we know that we have the opposite, because it's opposite the angle, which is this 12 over here, and we also have the adjacent, which is next to the angle, which is this 2 root 97. So you can say that tan of x is equal to the opposite 12 over the adjacent. So x is equal to inverse tan of 12 over 2 root 97. So we can do tan to the minus 1 of 12 over 12 2 root 97, which is the answer from the previous question, so I can just press answer. So we get 31.4. Bosh. Okay, next question. We've got side lengths of 6, and it is a cube, which means all sides are the same. T is the midpoint of AB. Okay, so I know that that's 3 on this side and 3 on that side. And V is the midpoint of CH, so again 3 on this side, 3 on this side. Work out the distance from T to V in a straight line through the cube. Okay, so we draw on that line there, T to V, like so. And then, again, the best thing to do is always to draw a straight line down from the point which is like at the top, and then connect along the base at the bottom. Just like that, because that will create a right angle. Okay, so we know one side already, this yellow side, because that is the height of the whole cube, so that is 6. So the side which we need to work out in order to use Pythagoras on this red triangle is this blue side here. Now if I draw the base as a square, because it's a cube so the base is a square, then we know that we have V over here. Because T was the midpoint, when it came straight down it would hit the midpoint of DC. So this is the blue line that we need to work out. And we know that this is free, and this is free, and this is free. So in order to work out the blue line, we need to do, let's call it x, we need to do the square root of the two short sides, because it is the hypotenuse we're trying to find, and both of those short sides are free. So don't need a calculator for that, because that's 9 plus 9, so it's the square root of 18. So just leave it like that, that's fine. Okay, now we've got enough information on our red triangle over there to work out TV. So that again is the hypotenuse of this red triangle, and one of the short sides is 6, and the other one is the square root of 18, as we've just worked out. Okay, again, we don't actually need a calculator for this, because it does say give our answer as a surd. So we've got 6 squared, which is 36, and when we do the square root of 18 and then we square it, well, those are two inverse operations, so they cancel out. So it's just 18. Which means this is the square root of, adding those two together, 54. And that's it. Bosh, done. Okay, this was a tricky question. We've got a prism which has a trapezium front or cross section, which is obviously going to be pushed all the way back by 24 centimeters to form the prism. And we also know that AD is parallel to BC. Yep, that's fine. And we have this, and it says that those are rectangles, and it says that BC is vertically above the midpoint of AD. Right. Okay, so the midpoint, okay, so the midpoint up here is vertically above the midpoint down here. So that means that this is an isosceles, it means it's an isosceles trapezium. Because it has a line of symmetry, essentially, because the midpoints are above each other. Okay, and there, yep, so the perpendicular distance between AD and BC is 20. Okay, perfect. Work out the total surface area of the prism. Okay, so what we'll need to do first is, let's work out the trapeziums. So the trapeziums, of which there are 2, so let's call it T for trapeziums. There are 2 of those trapeziums, one at the front, one at the back. And to work out the area for trapezium, it is a half of the 2 parallel sides added together, which will be 28, because 28 is BC, because it's the same as GF, plus 37, because that's the other parallel side down the bottom. And then we're going to multiply that through by the distance between the 2 parallel sides, which is 20. Okay, lovely. So we could do that on our calculator just to get a value there. So it'll be, let's just do 28 plus 37, and then times it by 20, because the half of the 2 will cancel out. So 1300. Okay, great. Now we need the rectangles, of which there are 4 rectangles. So there is this one multiplied by this, which we don't know that diagonal length yet. So what we need to do is draw a dotted line down here, like so, and that dotted line is just the height of the trapezium. So that dotted line is 20, and then this distance in here, let's just highlight it blue, that distance in there Well, how are we going to find that distance? Let's call it x. Well, on the other side, we can do exactly the same thing because of the symmetry, which we already pointed out. We could do 20, and this distance will be exactly the same. It will be x, like that. So we can do, to find 2 x's, we can say that 2 x's is equal to 37 minus the 28 at the top, because that distance across there is 28. So if I take it away from 37, I'm left with the 2 x's. Okay, so 2 x's is equal to, what is 9? Which means that x is equal to 4.5. Okay, so why is that useful? Well, it's useful now because then we can use Pythagoras to work out this distance here, this yellow distance. Let's call that y. So y is going to equal the square root of, again it's a hypotenuse, so we'll do the 2 short sides, which are 20, and 4.5 squared. Okay, so we can do that on our calculator, because that's not going to give us a too nice number. And we'll get, okay, 20.5. Okay, so now we can start working out the areas of the rectangle. So the first one will be 24 times by the 20.5. The one at the top will be 24 times 28. The other one on the side over here is the same as the first one we did, which is 24 times by 20.5. And the base is going to be 37 times 24. What you'll notice is when you work out each of these rectangles, they all actually have a width of 24. So you can do 24 times by each of them, so you kind of like factorize out the 24. Just makes it slightly quicker when you're adding them up on your calculator. But it should give you the same thing, of course. Great. So it should give us that. 2544. Okay, so we're good now. The total surface area is the 2 trapeziums plus the 4 rectangles. And that covers the whole area of the shape. So we get 3844 centimeters squared. Bosh. Okay, the next part of the question says calculate the size of the angle between AF and the plane ADEH. Well, first off, the plane ADEH is the base, and in order to find AF, we're going to have to draw the line AF on. Let's just get rid of some of this working. I think I'll keep that, it might be useful. So A to F looks like this. We then draw a line directly down from the point at the top, and then we draw a line across that plane to make up a right angle triangle. Okay, so this side over here is 20, that's the height of the trapezium. And we need another side length. So the side length I'm going to find is the one on the bottom. Let's call it Z. Okay, so in order to find Z, I'm going to need to draw the base of this shape out. And A is in the corner, and it goes up to around about there. So it doesn't go all the way to E. Now what is that distance? How far away from E is it? Well, it's X from the previous question, because it's perfectly symmetrical on either side, and X is 4.5. So if that's 4.5 in there, then how far is it over to H on the other side? Well, that whole base is 36 width, so 37. So we'll need to do 37 minus 4.5, which gives us 32.5. So we've got 32.5 is this distance across here, and then A to H is 24 because it's the same as D to E. Okay, so now what we can do is we can work out Z using Pythagoras' theorem. So it's going to be the square root of the two short sides, because again it's the hypotenuse. So it'll be 24 squared and 32.5 squared. Okay, so we can do the square root of 24 squared plus 32.5 squared, and we get 40.4. Okay, so next what we can do is use this purple triangle to work out the angle. Let's call it theta. Okay, so we can say that tan of theta is equal to the opposite, which is 20, over the adjacent, which is Z, which we know is 40.4. So then we do tan to the negative 1, or inverse tan of 20 over 40.4. And that should be good to go. So we'll do inverse tan of 20 over the previous answer, and we get 26.3. And that's the answer to part B. Okay, question 19. We've got the diagram shows a solid cone, and the base of the cone is a horizontal circle. Yeah, yada yada yada. Radius is 4.5. That's all I care about. And the diameter at the base, OV, is directly above. Yeah. The curved surface area of the cone is 130. Right, that's useful. So the curved surface area is a formula you're given, and it is pi RL, where L is the slanted height of the cone. So we know that it's 130, and we know this is 4.5, the radius, so we should be able to work out L by reversing this equation, or solving it, should I say. So it will be 130 divided by pi and divided by 4.5, so the same as dividing by 4.5 times pi. Okay, great, so that's 9.20 to 2 decimal places. That should be enough degree of accuracy. Okay, and now, what are we going to do now? I think I might use the cosine rule. Yeah. Or, no, actually, no, I don't need to use the cosine rule because it's perfectly symmetrical. I can just work out this angle and then double it. Okay, so theta is, what do we know? We know the opposite, we know opposite theta, and we also know the hypotenuse of this right angle. So just draw the right angle in so you know what I'm talking about. This right angle triangle here. Okay, so that's sine. So we can say that sine theta is equal to the opposite, which is 4.5, over the hypotenuse, which is 9.20. So we can work out that by doing inverse sine of 4.5 over 9.20. So we go inverse sine of 45 over the previous answer. Oh, sorry, 4.5. There we go. 29.3. Okay, so AVB, Andre versus Boas, is equal to 2 lots of theta, which is 2 times 2.93, or 29.3. And that is going to give us 58.6 degrees. Perfect. Okay, next question, and we've got a triangular based prism, and it says calculate the size of the angle between AD and the base ABEF. No problem. So A to D, we'll draw that line on first, like so. We'll then draw a horizontal line down, vertical line down, and then we'll connect it up along the base, and that will form a right angle triangle. And then we just need to work out the angle in here, we'll call that theta. So we need to find out at least two side lengths of this purple triangle. I don't know any at the moment, but what I do know are all these sides are the same, which means it is a isosceles triangle. So I can draw this isosceles triangle on like so. It's got 10 there, 12 and 12. And the one at the back, which is DFE, you can see we've drawn that line directly down the middle. So it'd be useful to work out what that is. Let's call it the height of that triangle. So we can use Pythagoras on this because we know that this will be 5 because the line cuts perfect line of symmetry because it's isosceles. So we have h squared plus 5 squared is equal to 12 squared, which means h squared is equal to 12 squared minus 5 squared. So h is equal to the square root of 12 squared minus 5 squared. Okay, and this is equal to, we can find on our calculators, so it's the square root of 12 squared minus 5 squared. Okay, fine. So let's just leave it like that. Root 119. Okay, so that's one side length of the purple right angle triangle over there. So now we need to find another one, and we'll find this side along the base, like so. So what I need to do is draw the base out, which is a rectangle like this, and I want to go from A in the corner to the midpoint on this side. That's what I want to do. So the midpoint means that that side there will be 5, 5 and 5, and we know that the length of the rectangular base is 15. So let's call this x. So that's the hypotenuse, so x squared is equal to 5 squared plus 15 squared. So x is equal to the square root of 5 squared plus 15 squared, which is 15 squared plus 5 squared, okay, 5 root 10, lovely. Okay, right, we're good to go. So now we're looking at the purple right angle triangle inside the inside the prism. We can say that tan theta is equal to the opposite, which is this side h, which we knew was 119 rooted, over the adjacent, which was this side here, which is x. So that's root 5 root 10. So we just need to do the inverse of that to get our final answer, and we'll just do that on our calculator. So inverse tan of root 119 over the previous answer, and we get 34.6. Beautiful. Okay, next question, and we have an isosceles triangle in a horizontal plane, and T is vertically above B. Okay, great. M is the midpoint of AC, and it says calculate the size of the angle between MT and the horizontal plane. Okay, so we've already got MT drawn on, and we've already got the straight line coming down vertically, so all we need to do is just connect them up along the base, like so. Because M is the midpoint, it's going to split this angle in half, so we can write 70 on both sides. And all we need actually to work out the angle in this purple triangle is one more side, because we already have this side length being 10. So let's work out this one here. And in fact, to do that, I'm going to use this this blue triangle, which I'm going to create here. So I'll just sketch that in 2D. So it's going to look like this. We're going to have 70 degrees at the top. 8 is going to be the hypotenuse. There's going to be a right angle here, and the side we're looking for is this side. We'll call it X, and it looks like that on that diagram. Okay, so that is the X is adjacent to the angle 70, and 8 is the hypotenuse. So we're going to use cosine. Cosine 70 is equal to the adjacent over the hypotenuse. So rearranging this formula, we have that X is equal to 8 cosine 70. Okay, we can work out a value for that. So that is just 8 cosine 70. So it's 2.74. Okay, and now we can switch our attention to the purple triangle and alpha, theta, and theta in this triangle, opposite it is 10, and adjacent to it is x. So we can say that tan of theta is equal to opposite over adjacent, like so. So therefore, theta is equal to tan to the minus 1 of 10 over 2.74. So we just go tan to the minus 1 of 10 over the previous answer, and we get an answer of 74.7 degrees. Voila. Okay, the final question, and it is a beast, if I remember correctly. I think I've done this question before. Yes, so first off, people find this challenging because there's no side lengths given. So you have to just attribute them or sign them yourself. And it says that EF is 2 lots of AE. Okay, now we're also going to be splitting GF in half. We can see the midpoint there. So what I'll do is I'll attribute some side lengths. I'm going to call this side here 1 and 1 either side, which means that the whole length across the base is 2. And because EF is 2 times 2E, it means this side length will be 4. I mean, it literally doesn't matter, as long you could have picked 10 or 20, or you could have picked any number, as long as you keep it consistent. Okay, so it's a square, so it means that these heights are 2, and it obviously means that this is 2 on this side as well. And because we've got an equilateral triangle, it means that this side length is 2 and that side length is 2 as well. And it's asking me to work out the angle MAJ. Okay, so I'll draw that on purple. So I'll go from M to A, and then from A to J, and then I'll need to draw a line straight down connecting M and J. Okay, so let's first look, and I'm going to need to find this angle in here, which is Y. So, and that's a right angle there. So again, I need 2 side lengths of this purple triangle, and the first one we'll find by doing the base. So I think that's the easiest one. Okay, so the base looks like this. We've got A in the corner, we've got G over here, and we've got M in the middle here. And the purple line, which we need to find, is connecting A and M, like that. So we know that GM is 1, that's what we assigned it to be, and AG is the same as EF, which is 4, like that. So in order for me to find A to M, then it's the hypotenuse, so it's the square root of 1 squared plus 4 squared, using Pythagoras' theorem, which is just the square root of 17. So let's leave it like that, because I can see already the answer wants it in exact form. So there's no need to write it out as any decimals. Okay, now the next side length which we can work out is m to j. Now I know that m all the way up to that dotted line is 2 because it's the height of the triangle. What I don't know is the height that also needs to be added on, which is the height of the equilateral triangle. So what I can do is I can draw the equilateral triangle out like so. So that will be h, that will be j, that will be k. And I know that it has these side lengths of 2 on that side. And if I draw the height which I'm looking for, which is straight down, then let's just pick this left-hand side, or right-hand side, sorry. It's a right angle triangle, and from there to there will be 1. So this little bit here, I'll call it x, and that's going to be equal to, again using Pythagoras' theorem, it will be the long side squared minus the short side squared to find the other short side, which is the square root of 3. Okay, so that means that m to j is 2 plus the square root of 3. Because we have to add this bit here 2, and then that part is x, which is square root 3. Okay, so now we can look at the purple triangle and we can work out y. Now, again, I probably should have mentioned this first, but it says tan of y. So we're going to be using tan, which is perfect for us because we've worked out the opposite side length, which was mj, and we also know that the adjacent side length, which is root 17. So we can say that tan of y is equal to the opposite, which is 2 plus root 3, over the adjacent, which is the square root of 17. But they want it in this particular form, so that means that we're going to have to rationalise the denominator. So we do that by multiplying top and bottom by the denominator, which is root 17. This gives me 2 root 17 and root 3 times root 17. And then now that'll be all over root 17 times root 17, which is 17. Okay, that all of the numerator has to be a square root. So this, we can rewrite that as root 4, because root 4 is the same as 2. So we get this, and that's all over 17. And then we can combine those square roots that are multiplied by using the square root, our square root knowledge, which means we basically just multiply those numbers together. So 4 times 17 is 68, and 3 times 17, triple 17, we all know that from our darts, is 51. So that is our final answer. Gosh, what a great question that was.